machine learning has had a huge impact across all of computer science, but particularly in the areas of artificial intelligence. I'm Tom Dietterich. I'm Distinguished Professor Emeritus at Oregon State University, and I'm an expert in machine learning. I was among the first cohort of graduate students to work in the area that has come to be known as machine learning. So what is machine learning? Well, it's a way of programming computers that sidesteps the problem of having to know exactly what step-by-step instructions to give the computer. Traditionally, a programmer develops a recipe, an algorithm, and then writes a program in a programming language to instruct the computer how to work. So an alternative methodology, the machine learning methodology, was to collect so-called training examples. So for instance, if we want to teach a computer to tell the difference between a wolf, say, and a dog, we could collect images that contain wolves, images that contain dogs, and maybe images that didn't contain anything. Now, unfortunately, sometimes the machine learning algorithm will pick up a spurious correlation. And this happened in the wolf-dog case. It turned out that most of the images of wolves that had been taken were taken against a snowy background. And the machine learning algorithm identified that as being the most obvious correlation. And so it decided whenever an animal is in front of snow, it must be a wolf, and when it's in front of grass, it must be a dog. And the problem here is that it's found so-called spurious correlation that doesn't correspond to the causal reason why it's a wolf and or a dog. And that's an area where I think we will see the next big breakthrough in machine learning. And we have our own expert at Oregon State, Kartika Mohan, and I think that the work she's doing will be a step toward a sort of causal revolution for machine learning. Another weakness with machine learning that we've been working on a lot at Oregon State is the problem of novelty. And so, for example, the Volvo, when they build their cars in Sweden, they include a deer detector because car-deer collisions are a major problem in Sweden. I mean, they're a problem in Oregon too, but evidently more in Sweden. And so they developed a computer vision system that can detect the deer and apply emergency brakes. But when they took these cars to Australia and a kangaroo hops in front of the car, it was completely confused because it didn't know whether to put the brakes on or not. And it behaved very unpredictably. And so that's an example where we'd really like the system to say, oh, this is something new. I've never seen this before. Let me slow down because the best thing to do is to stop. So that's an area where we've been doing a lot of research at Oregon State University over the last 15 years on how to detect novelty and then how to respond appropriately. And our work has had an impact in cybersecurity with novel cyber attacks, in manufacturing with novel manufacturing failures, and a whole host of other areas. Artificial intelligence is an even larger umbrella field that includes every kind of computation that we would regard as intelligent behavior if we saw it in humans or animals, or even aliens. Machine learning is just one way of constructing intelligent systems. In recent years, it has become the dominant way, and we've seen huge advances. And then specific forms of machine learning, such as computer vision, speech understanding and recognition, and language understanding.